Oh, sorry. Start the recording.
Yeah, it's okay. That's a lot to cover here, and I have what 20 minutes and some Q&A. But what we do basically in Ectors is that we design and we design, test, and certify electronics, and we also have a factory in the small group. So we're not a product company; we are a service provider. And my own background is that I've been working with testing and certification for a quarter of a century in different companies, and the last 15 years in Ectors, which I co-founded some 15 years ago with one of my colleagues. And basically now we own and at least operate two state-accredited test labs. And besides that, we do a lot of non-accredited testing and reliability testing, and that happens in Struer and in Hvidovre, near København. And we have a huge network on the test and certification side of things, so we can really help people go global if that's what you want. Okay, so why do we want to test at all? Does it create any value to test? I think it does. There are three main reasons for testing. The first reason is to meet regulatory requirements, law requirements, to be able to document that you actually meet state rules or government rules and regulations, so you are even allowed to sell the products in the markets. I think this is pretty common knowledge that there are some law requirements in most countries, and they are being exercised or implemented or enforced, I should rather say, with the various degrees. But at least for Europe, we have the CE marking, which is pretty commonly known. It's a very broad topic, crazy broad. We have now the UKCA for Great Britain. We have FCC 15 and other FCC standards for the US. We have IC for Canada, CETIC for Australia, and maybe New Zealand and other things across the globe. We got South Korea, Japan, other things, other markets that could be of interest in general to electronic products. But why test? Well, you want to be able to sell your product in a lawful way. Second reason for testing is that you want to meet certain functional requirements of your product. Maybe the law does not require this testing to be done, but you want to demonstrate or prove to customers and maybe to competitors that the product has certain features, qualities or properties. And quite often qualities and properties that exceed the regulatory requirements. So maybe your product is legal, it's legalized, but you want to be better than the competitor. And meeting tougher testing requirements is one way of doing it, if it creates value for your customer. And the third reason for testing is to look into the product quality and the reliability. I mean, there's no law, basically there's no law prohibiting you selling crappy products, but you don't want to do it to the extent that it hurts your business. So there's a number of disciplines that could be of interest to you, including reliability and operational life, to be aware of where your product is situated in the markets and what kind of value or disvalue it creates for your customers if you have a crappy product. So what I'll be doing today, I'll talk about today, is mainly the regulatory requirements, because that's like, you know, the minimum of set of requirements you have to meet with your products, or you have to deal with if you're working as a consultant for product companies. And I will focus on the EU directives in daily words. We call it the CE marking, which is a very broad range of common EU regulations. They're common to the EU countries, in short. And basically what it does is that, or what the EU directives do is that they enable a single market approach, meaning that if you can sell your products in Denmark, you can sell them all over the EU. without having additional requirements. Naturally, there are some exceptions to that rule, but in general, that's what applies for electrical and electronic products. So basically, the directives, they harmonize the different national requirements to your type of product. And so that's a huge advantage, especially for companies coming from small markets, small countries like Denmark and other places. I dare say that it's thanks to the EU directives and the CE marking approach in general that the Danish industry has been able, at least partly due to that, the Danish industry has been able to be so successful globally and Europe-wide. One note here, though, is that EU directives, they put the responsibility, they place the responsibility of compliance on the manufacturers. If a manufacturer is not European, then that legal entity does not exist. So the importer or the reseller becomes legally responsible for the product. I'll be talking a bit more about that later on. Got some great examples of how things can go wrong. Let's see if we got time to talk about it. I'll be focusing on 3 EU directives. The Low Voltage Directive, which basically guarantees or helps ensure that the electronic and electrical equipment is safe. It's one of the 2 most important directives when we are talking about machines and electrical devices. We got the EMC directive, which deals with electromagnetic interference and compatibility of electronic devices and electrical equipment. I think most people are acquainted with those 2 directives. And then we got the radio equipment directive, which basically ensures or sets the framework for coexistence of radio-based equipment. And I will focus on those 3 directives in a few slides in a minute. There's a multitude of other directives, from pharmaceuticals to toys to you name it, cars, safety of machines. Which directives apply to your product is something which you have to decide, basically, or you can use some consultants to help you decide which apply. But it's a wilderness, it's a jungle. So I will just be focusing on these 3 directives today. The Low Voltage Directive. The basic scope is to ensure that electrical equipment is safe. The user is protected, and it's only valid for equipment within a certain voltage range. It's a safety directive, safety first, and by safety directive, I mean that if you sell a product which is perhaps not safe, and you have some degree of awareness that it may not be safe, then you could be penalized quite severely. The same goes for the machinery directive and a few other directives. Depending on the place, you will get pulled to court, but you have to really take it seriously. If you sell a product what you know is unsafe and you knew it when placing it on the market, it could mean up to 2 years imprisonment. And the Low Voltage Directive covers various types of equipment, from household products in any sense, commercial products, industrial equipment, cables, power supplies, you name it. Anything which may become dangerous or catch fire if there's a fault in it of some kind. And there are no exceptions from the Low Voltage Directive. I quite often get questions from people saying, well, it's only a prototype, so we don't have to comply. With the directives, that's generally false. But in particular, when it comes to safety, everybody has a right to be safe. That person that gets electrocuted by a single prototype doesn't really care if it's one prototype only or volume product. So there are no exceptions. All products being used, placed on the market or sold have to be safe, period. A few specifics. And the low voltage directive, it covers normal equipment with a rated voltage of 50 to 1,000 volts AC, or the equivalent on the direct current side. So it covers pretty much everything that we deal with. It covers, it comprises references that were low voltage directive to a lot of generic or product type specific standards. They've all been harmonized. That's the word. If a standard can be used as part of the LVD compliance work, it has been harmonized by the directive. So it means it's acknowledged across the EU for compliance, state compliance with reasonable rules and regulations. The low voltage directive actually also deals with fire safety and mechanical properties and thermal concerns. For example, overheating, too hot surfaces. Does some kind of plastic catch fire if it becomes too hot, or if there's a single fault in the device? So it's not just about doing the high voltage safety test, then you're good to go. There are some more concerns built in. And well, I already mentioned those. The electric testing or high voltage testing, continuity test, if you have a protective earth connection, temperature rise, single fault climatic testing. That's what you have to consider. Not to overcomplicate things, but these are just the main things to look at. Another thing is that although we normally do most of the testing in the design phase or the certification phase, the low voltage directive, depending on what standard is being used to declare compliance, it may require that testing be done also on the production line. So we're talking about serial production testing here. And that has to be looked into very, very carefully. You don't want to send out 10,000 power supplies and finding out after 6 months that you've made a mistake. Because if somebody at some point gets a little electrical shock and you cannot bring evidence forward that you didn't in fact test on the production line, then you would be liable. So once everything is done, you design it, you do the certification, you can apply the CE mark. You saw the CE logo before, everybody knows it. But not only that, to have a legally CE mark, you must have ready a technical file describing the test, the design consideration. You must have that ready at hand. And then you can legally sell the product. You don't have to send the technical file. You don't have to submit it with the product. You don't have to make a certificate as such, but you have to issue a declaration of conformity. I didn't mention that here by mistake, but a declaration of conformity basically is a piece of paper which you sign as a manufacturer, stating that this product is indeed legal to sell, and you declare to which directives and to which standards. The DOC, the Declaration of Conformity, does not have to be shipped with the product, but again, you must have it ready at hand. And if you look in many manuals, the user manuals, it's actually in the user manual. Not anybody can sign the Declaration of Conformity. It's the person who represents the legal entity in charge that can sign it. Okay. Low voltage directive, still safety first. Compliance has to be declared by the manufacturer or the importer or the reseller. You can't rely on CE marking being made by a manufacturer in China, not legally at least. How about example, a power supply? You buy a USB charger, something from a manufacturer in the Far East. They have CE marking, they have made declaration of conformity, it's all good. Only that it's not. Meaning that if there's a problem with that device, then you would be liable because you imported to the EU area. The Danish safety agency, Sikkerhedsstyrelsen, has 0 jurisdiction in China, but they would have jurisdiction over you. And this is, by the way, why all major chains, resellers of electronics and goods, including Polka and those shops, they rarely import electronics themselves. They have some small import companies that import it because then Polka is not legally responsible for the product, just as a side note. think about that the next time you buy a 50 DKK USB charger. Dealing with safety is not just a question about compliance or not just a legal matter. In my opinion, it's first and foremost an ethical obligation to protect others. You could comply with all the standards, but if somebody gets injured or gets killed, having complied with the law does not really help them. So there's a certain element of morally correct behavior built in this also. I don't want to be like I don't want to preach anything, but you have to think about it. And there's an objective responsibility built into the Low Voltage Directive, being a safety directive. Let's say I sold a product. I knew that it could potentially be unsafe, and somebody gets injured. When I wind up in the Danish courtroom, a Danish judge would not look so much at the legal, the formal responsibility. He would look at, if somebody could have prevented this happening, who would that have been? and as an importer manufacturer, you are always first in line. Always. I have a one-liner on how to deal with safety, electrical safety. We do not harm or kill humans or animals. Simple as that. Always bear that in mind. It's not like, yeah, it's going to be okay. Don't think like that. That's my take after 25 years of dealing with this. Now things got a bit grim. That's a practical side to things also. I encourage you to go and check out this guideline from the EU on the Low Voltage Directive. That guideline is not legally binding, but it's a really good, document helping you convert the formal requirements into something to do and something to think about. That was the top level of that. We have next the EMC directive, Electromagnetic Compatibility Directive, and the scope basically is that it helps regulate the requirements for electromagnetic interference between devices, meaning that electrical and electronic equipment should be able to coexist, so that two pieces of equipment do not disturb or get disturbed by each other. And why this? Well, I think everybody knows the practical examples of at least back when we had flow radio in the cars. You always knew when you would get a text message 1 to 2 seconds before it arrived, because the radio would start jittering. And the EMC directive covers various types of equipment, including like for low voltage equipment, low voltage directive equipment, the household products, commercial industrial equipment, power supplies, and all that. Anything and everything, basically, with a piece of electronics in. Like with the Low Voltage Directive, there's a huge number of specific standards that are harmonized to the directive. If there's not a product standard relevant for your product, then we have a set of standards called the generic standards, and they kind of set a set of reasonable requirements that help ensure coexistence with the requirements. So it has a good one. We have not 4 but 5 basic categories of tests that we carry out in the development phase when we have to deal with the EMC directive. Sorry about that. We do some radiator testing, meaning that how much noise do we transmit through the air onto other products or devices, and how much noise are we able to withstand from other devices, and the same on conducted noise, radio noise. And then there's a 5th category called transients. For example, we have a lightning strike somewhere in the power supply system that could lead to some very short-term, very high voltage peaks. Products should be able to withstand those transients also. It's actually part of the EMC directive, even though it's not EMC, basically. And we have normally 2 levels of test categories here, and what's normally used is the one called light industry / commercial / residential test levels. That's what being used for equipment, for offices, for homes, and for light industry and for entertainment. I mentioned before for the low voltage directive that we may have a requirement for production line testing. That rarely happens with the EMC directive. There could be a few special cases where you have highly customizable products where you would want to be able to prove that that single product is compliant with requirements, but that would be quite rarely. So, like with the low voltage directive, you do the testing, you wrap up the technical file and the test reporting, and you put the CE mark on the product, and you issue the declaration of conformity, where you state that you obey current law. I know this is quite fast. Third directive I want to talk about today is the radio equipment directive. It's a single market approach for telecom devices like for the others, but basically what the radio equipment directive does is that it deals with not just the noise being transmitted between devices, it also deals with the actual radio signal being employed by those devices. And it aims to ensure that devices are compatible, that they can coexist without losing performance too much or without causing any danger. A few years ago, I went 3-4 years ago, I went to a presentation made by Nokia in Copenhagen, a presentation on what they expected in the future of radio transmitting devices. And in an urban area, they expected 1 million transmitting or receiving devices per square kilometer. So that's one device per square meter. Different radio technologies to different frequencies. I cannot imagine them the frequency band, the frequency spectrum in that urban space. And the only reason that this is working in real life is because we have something like the Radio Equipment Directive and other regulations. That's why doors in apartment buildings don't unlock unintentionally when somebody picks up the phone. I could bring forward a swath of examples of that, but it's not a new thing. Basically, there was an old radio RTT directive, it's called in short, from 1999, but it was replaced by the current version almost 5 years ago. And I'm just mentioning this specifically because I know and I can imagine in the future that dealing with sound products in a broad sense, if not all of them, most of them would have some degree of wireless capability, and it has to be taken really seriously, not just for functional reasons, but also for compliance reasons. Basically, it covers all types of devices with a built-in radio receiver transmitter. I'll get back to that in a bit, but also until 5 years ago, until 2017, you had to decide. Let's say you had a refrigerator with a Bluetooth transmitter and receiver. You had to decide whether this product was a refrigerator or radio. After June 2016, the answer to that question is that it's both. So complexity of dealing with compliance actually exploded a bit back then. Yeah, that's not essential. There's an exception here from the compliance requirement. If you do R&D work, if you go to trade fairs with new prototypes and new products, the rules are somewhat relaxed, but there could still be some requirements or restrictions. So if you're in doubt about that, please consult with us and we will help you find out whether you could go or not without having done the final testing. Like with the other directives, you have to, a declaration of conformity has to be issued declaring compliance with the requirements. It can be issued by you or by a notified body if there are no harmonized standards. So it gets a bit more complex than with the other ones. I mean, this is a 40-page presentation that I had to boil down. But basically, the RD directive deals with a lot of details concerning safety and health, including human safety, because you may have a radio transmitter close to the tissue of your brain. It deals with the electromagnetic compatibility, and it also deals a lot with the efficient use of the radio spectrum available. Again, back to the coexistence, 1 million nodes in 1 square kilometer in central Copenhagen. That's a requirement. And then, because we talk about communication, there's a broad range of other things to be looked into, including privacy, data theft, disturbance of emergency services, a lot of other things. And as opposed to most other products, let's go to, I took that one out. Software is actually part of the product here. If you can have the exact same product, exact same hardware, exact same electromechanical properties. If you change the software, you have to go and do the testing again. Or you have to assess to which degree testing must be repeated. The reason for that obviously being that the majority of the modularity in many radio-based devices is defined by the software, changed in the software or firmware. And as opposed to EMC directives, the EMC directive for normal products and the low voltage directive for normal products, the testing has to be performed by an accredited test lab. And that's simply due to the level of complexity and the level of skills it takes to deal with this, to be even able to understand the radio standards. I myself have no clue about radio standards. I've got some great guys working for me who know about this. But it gets rather complex at some point. I quite often get the question, so we buy from customers that buy a pre-certified, certified radio module from somewhere. It may or may not fly, it's certified. We have to look into the test report actually, because somebody's jumping the lower end of the fence so many times when buying it in the Far East. And no matter what, there's always a minimum of tests that have to be carried out. But I can share that with you in individual talks. There's also a guideline on the radio equipment directive. I think these notes will be circulated later on, so people can see the references.
Yeah, that's correct.
But go and read those. Great guidelines, great notes on that, and don't get lost in the complexity, because there's always a path through things. So a bit back to which devices have to comply, because this is really important. This is taken from the directive itself. It says that basically any electrical or electronic product which emits and or receives radio waves for the purpose and so on are considered a device that has to be dealt with under this directive, and that's fine. I mean, even a simple receiver has to be tested, even though it does not transmit anything. And I've listed a number of wireless communication technologies, which are probably familiar to most of you. Covers pretty much everything we have seen so far, at least. And that's the game, no exceptions. Oh, here we have the note, the last bullet point about the software being a part of the actual device, also in a compliance testing sense. So if you change the software, you change the device, and you have to test to some degree, repeat the test one more time. So that was a lot about directives, and we were barely scratching the surface here, but I mentioned two other good reasons for doing testing. One is the functional requirement, testing to see to meet increased functional requirements. You might want to go beyond the standards and the law requirements, simply to get a better product. For example, to get an advantage over competitors. So your product is legal, You can sell it legally, but you want something which works better in the field, operates better in the field than the competition does. That's a good way of doing it. Without mentioning names, I could perhaps indicate some Danish industrial companies, maybe a major pump manufacturer in central Jutland. They always test 50% higher than they have to, simply to have some margin for error and for beating competition. To them, it's a strategic decision. This is how they want to be. They want to be known as the company with products that don't fail where competition fails. It could also be that you actually want to deal with real life conditions. As you have to bear in mind that a technical standard does not define the truth. It defines what a group of persons in a technical committee did not disagree about. So that could be elements in the real world that are not described in or covered by the standards. So you would want to test, do some extended testing or additional testing. Yeah, I mentioned electrical fields, operating environment, thermal properties of stressing, vibration during transportation, other things that you don't have to test, but you could do it. And then digging deep into the design and development side of things, you want to look into the reliability of your product always, or the product quality in a more common term. You should do accelerated limit testing. You have to understand the end-of-life failures that your customers will probably see at some point. Don't let the customers tell you where your product is weak. Try to understand it yourself before selling the product, or at least while selling the products. Dig into analysis tools, looking into useful life, operational life of the device. We can help you do that. You can do it yourself. I mean, there are no rules here. Seeing is believing. So start digging. That's the main message. Yeah, you could do FMEA and analysis and calculations. Another reason for looking into product quality, obviously, but also secondarily reliability is cost optimization. Product life cost of selling a product becomes too high if quality is too low. But if the quality is too high, if you build an aircraft carrier but you just need a rowboat, then you might want to optimize a bit on that. And one way of looking into that is by doing some testing, particularly if you have older generations of the same type of product. When you design the new version of the product, you want to look into how the endurance and the robustness of the new version also. So building too good products is too expensive also. Yeah. I want to make one side comment here about the CE marking. As you may or may not be aware, our neighbors to the west decided to leave the EU a while ago, and the CE marking in Great Britain was actually replaced by a UK CA marking. I do not want to get into the details of that. I still haven't got my head around things myself, to be honest. Not complete. I think nobody has. But as of January last year, the UK CA marking had to be used in Great Britain, not in Northern Ireland necessarily, but in Great Britain. Strangely enough, it's not called GBCA, but UKCA. The CE marking was still accepted until January this year. I'm just mentioning this because the British market is indeed a core market for many industrial and consumer products in Europe and globally. So please be aware of that. Talk to us about it if you have some concerns or some intentions of marketing your products and selling them in the UK. Basically, it's not so much a technical thing. It's more about cutting the red tape, having the right papers at the right place at the right time, as I understand it. This one doesn't really matter. Here's like a top level comparison of what kind of requirements have been replaced. CE mark requirements have been replaced by which UK CA requirements. and regulations in the UK. I'm not sure that this one is current, to be honest. I think one or two of those have been changed, but just to show you that it's a path forward here if you want to sell or want to keep selling your products in the UK. But it's a major concern for many manufacturers, and I think it should be for you too, if you want to go Europe-wide or maybe even global with your products. Okay. Just as a funny note, Northern Ireland is not part of Great Britain, so there was a Northern Ireland protocol that took effect when Great Britain left the EU, and there are some complications to that. So basically, the CE marking still applies in Northern Ireland. The big problems are not seen from the EU side, but I cannot imagine the trouble they've had to go through in the UK dealing with this division now between the Great Britain and Northern Ireland. So basically, that was the very quick and dirty version of how we see product testing and certification. I would like to encourage you to ask me some questions now or address me later on if you have some more specific questions. And I would like to make ourselves available for a later meeting or webinar, whatever it ends up being in specific areas or topics, for example, reliability or safety specifically, or maybe even radio testing, which is probably of major interest to a lot of you.
Thank you very much,
Yeah.
Niels Martin. I'm surprised to learn about the differing rules between Northern Ireland and Great Britain.
Oh, I think everybody
is.
My
home country.
Yeah.
Okay. That's tricky. So that means that if your product was previously certified for the sale in the UK before that, everyone had to go back and retest?
The retest are as a minimum convert to the new requirements for paperwork. To be honest, I'm not that much into those things myself. We have encountered it a few times over the past years. There's one more exception which is still valid until January 23, but we keep telling people that they might as well adjust to the new reality if they want to be on the British Isles. So,
and does that equate to like a whole other? Are there things that is there an overlap, or is it like twice as much testing?
No, basically it's the same requirements. So,
okay.
For now, because the references from the legislative framework are pretty much the same until now to the international technical standards being used. But different way of declaring compliance is a different mark, and I think there's an emotional element to this, that now the Great Britain decided to split ways with EU, so now they better bloody do it and demonstrate it. I mean, the grace period for transfer was quite short, 1 maybe 2 years. Quite short and effective. I don't know more about the legal side of things than I just mentioned here, but technically, the products are the way the products are, and the technical standards define more or less common sense. So I wouldn't be too concerned about the technical matters here.
Okay.
I would be concerned about not complying with the paperwork. So if you sell the product for 1 year, and you could be forced to make a recall or do something because the marking was not correct
at the time of sale.
At the time of sale,
yeah. Have you experienced customers who just aren't bothered with selling to the UK anymore?
Oh yeah.
Yeah. Okay.
But to the same degree as I experienced customers who don't care about importing whatever they can find from the Far East and selling it in Denmark without bothering about compliance, because that happens too a lot.
Yeah.
Still.
Do we have any questions from our audience or from Peter Peterson?
Yes, I have a question, Niels Martin,
Sure.
because you explained you could say the mandatory testing, but also the testing that you would like to do in order to ensure a quality product.
Yes.
If we go to you and I'm sure we get guided as to which tests are mandatory. What about you said real world tests?
Yeah.
To be able to recommend a manufacturer some good real life tests that are not mandatory, but that it would be good to meet.
Yes, we would. Obviously, we are not the expert in the customer's product. The customer has the domain knowledge, but we kind of understand most things, a lot at least. And what we can also bring is some what can we say, cross domain experience and knowledge. I didn't want to roll out the sales presentation or anything here, but what we deal with in Nexus testing is all kind of products. We have a sister division that develops products on behalf of customers, and we develop products from medical devices through defense to wind turbine controllers, and they don't have a whole lot in common application-wise, but implementation-wise and reliability-wise, there's a lot of commonality, and we kind of lean on our experience across the application domains for that. And what we normally do is, if we get approached or when we get approached by a customer, what we do is we go and kind of quiz the customer about the use of the product, about the specification, and in particular about the failures that they've experienced, the quality statistics, because that's why we want to dig deep to solve the problems. And in this way, we encourage the customer to go and be open about the weak points. Like I said earlier, you might as well, as a product manufacturer, look into where your product is weak, because if it's too weak, your customers will tell you, and that's not pleasant.
You have to find out before the customer.
Yeah, one of the best examples of a very mature approach to that is actually the same pump manufacturer I mentioned before. Could also be a wind turbine manufacturer, which is headquartered in Aarhus. Probably 15 years ago, they started to tell their suppliers of key components. They asked them or invited them to come and do reliability testing and environmental testing free of charge in the lab in Aarhus. They had no requirements for performance or reliability or anything. They had one requirement. It was the supplier of the component had to share with them transparently their findings, their weak points of the product. Because if the Finnish supplier of ultrasonic wind measurement equipment did not share that, then Vestas would tell them 5 years later. So as simple as that. It's a very mature approach, and like I said earlier, seeing is believing, so you better start digging. We can do that in Nexus. We have the lab hosted by you in Struer, and we have also the colleagues in our development division who can pitch in, because they have great experience actually developing the product, not just testing, but developing products that should be able to withstand 5, 10, 15, 20 years of operational life.
Yeah, I have another. It's not a question, it's more a comment, because I think this field, you could say, call it the gray area, that I imagine there's a need to share experiences between manufacturers to the sound domain, because this is a question of finding out the right level and improving the product reliability and performance over time. So I think it would be a good subject for experience sharing between companies. And of course, testing labs as yours.
No, I completely agree. And testing is one thing, and the other thing is rules of thumb, common knowledge, common sense, de-rating of components and power supplies. You know, all the good old classics, which are easily forgotten. We see that in particular with startups. They're forgotten. People put hopes higher than experience or something, and it all accumulates. It all builds up. Helps build a strong product where you can make money as a product manufacturer, as a supplier, or as an importer, and the customer is happy. He wants to buy the next time, 5, 10 years down the road. As a small anecdote, I can tell you that I've been working with this for so many years. I used to know an old American guy called Charlie, and he would talk about reliability and Gaussian distributions of failure modes and all that. And after 2 hours of waving his arms the American way, he would end each presentation with showing a heap of money and saying, "This is what it's all about. Go check your return area, your quality area, because it's a freaking gold mine." So it's not just about compliance; it's also about having a profitable product.
And I think I'd just like to mention that with such a big focus on sustainability and creating products that have a longer lifetime, especially in the electronics industry, testing is going to become even more important over time.
Yes.
Yeah, that's what we're hearing from the companies we're visiting. So I think we should move on to Thor's presentation for now, and then we can come back to the discussion again afterwards. But thank you very much for that overview. Very high-speed overview of everything you're working on.
High and dry, I know,
yes.
but there you go.
It was a good introduction. Thor, are you there and ready?
I'm here.
Excellent.
And I think I'm ready.
You think you're ready?
Yeah, let's see if I can figure out how to share my screen.
Yes. Excellent. Looks good. So Thor is a senior audio specialist, is that correct, at Force Technology in Hørsholm, where we also have an office. The Danish Sound Cluster has an office here as well. And Thor has been working with audio performance of products for over 10 years, and that's both on the objective and subjective side of things. So we're going to hear a little bit about the specifics within audio evaluation. So thanks a lot for being here.
Yeah, thank you. And thank you for the introduction. Yeah, so my name is Thor, and just a little disclaimer here about the title, acoustic testing and team certification. I actually don't know very much about team certification, so I've been Googling a lot, and I'm sure that some of the people in the audience might be able to correct me a bit if I say something that's not 100% correct. But let's go. So the background, this slide is almost identical to the one we saw before, that every device is tested in terms of its safety, and it's at least in Europe, it's CE approved. And so you know that when you're wearing your headset, the risk of it exploding is very small. The risk of your pencil breaking your arm is very small. I think pencils are CE approved. I don't know. I assume they are. So you know that your products are reasonably safe. You also, in some cases, know that your product is reliable. Probably more so in like a military, a hospital, a space grade things. So reliability and safety are sort of secured in any product to some extent that we have. But I don't know if any of you have heard, I guess, in movies and whatever, sound from one of these helmets or even from a helicopter or something. And to me, at least, it doesn't sound very good. So that brings me to the point here that there are none, or at least very few, requirements for quality, product quality, or at least audio quality in these standards that people are following. There is a little bit in international organizations that have created their own standards for communication networks, like your mobile phone, for TV broadcast and stuff like that. So they do have audio quality requirements, but for the consumer who buys a headset, there's no guarantee that it's good. And yeah, as we heard before, it might not even be okay. It might be like really crap. So of course we all want to make good products that give the user a good experience. So what can we do? And I split this up into very sort of simplified two situations. And one is the single user scenario. So someone listening to audio. And that's not really the focus of this. It's more of the communication side, where we have multiple users and maybe multiple products interacting with different types of software. And it's much more complex. So the communication scenario. So what we do is we I guess what we should do, make sure that systems talk to each other in the same way. They expect the same input-output levels, agree on noise, echo canceling technology and stuff like that. So we don't do double noise canceling that might do something weird to the sound, or if two echo cancelers somehow interact with each other and create something weird. Some of this is handled via standardized interfaces like USB, Bluetooth, all of this stuff, but there's a lot of stuff that is not. And so what we can do is we can follow these guidelines or standards for product design. And of course, it shouldn't be in the way of innovation in our products, but it's a good way to make sure that some of the obvious errors are avoided. So like a bunch of distortion in the loudspeaker or something like that. And then of course we can implement quality and performance testing to avoid this. And how do we do this? We measure technical performance. You can measure frequency responses and all kinds of things, as we all know. We can measure the user experience, and then also we need to trust the users when they disagree with our technical measurements, because they do sometimes. And I just want to also share a little anecdote. We had a company that contacted us about a new, what's it called, like a smart speaker home assistant device that they were building, and they wanted us to test it with a bunch of consumers. And they wanted to do this regularly so that they could implement the results in their audio tuning. So we started giving them results, and they were not very good. Their product did not sound nice. It was harsh and distorting and too sort of bright. And then they decided that they didn't like this feedback, so they stopped doing these tests with us, and the product ended up being an epic failure because of this, or at least it's famous for its terrible audio quality. So it's just to say, please take the users seriously. And what can we do? Also, we can of course get certified somehow, sort of like the CE, but there's no legal parts in it. And the certifications I could find for audio product quality in this area are like the Google Meet hardware peripheral qualification program, that's very long, Zoom hardware certification program, and in the title, Microsoft Teams certification. So what I started out with, I Googled this Google Meet certification. I wanted to find some of the specs so I could show it to you. And the result was no. Google doesn't want you to know what is in their qualification program unless you contact them and actually actively have a product involved in this process. So that's proprietary. Then I tried Zoom, the Zoom hardware certification program. You can get this little logo on your package, on your headset, a conference speaker, whatever it is. And I Googled, and no, they also don't want anyone to know how to meet the standards, which is really puzzling to me. So then I tried the last one, and you can see now that this might be a really short presentation. I Googled Microsoft Teams specs, and fortunately, I found 143 pages on the audio tests alone. There's also a bunch of information, probably almost as much on video tests, and there's general design guidelines for like where's the button supposed to be, and of course there's supposed to be an MS Teams button on your Microsoft Teams certified product. And I put just some rough numbers here on the amount of tests, and it's a lot. This is just a small part of it. And it's split between both objective measurement, and there's also a few tests where some, let's call them domain experts, run a test with an active Microsoft Teams call and then try to do things, and we'll come back to that. And then some parts of this are still not available to the public. It's strange. And as you can understand, 143 pages on audio alone is way too much to go through. So I will just do like a little curated thing for you where I show some of them. So in terms of hardware and software, what do you need to run these certification measurements for Microsoft Teams? You need several rooms. with specific reverberation times and sizes. Some of them could be meeting rooms with notifications. You also need anechoic chamber, and you probably also need like an actual listening room. Then you need a bunch of acoustic measurement equipment, hardware and software. You need a head and torso simulator. You need other microphones. You need calibrators for those and power supplies, loudspeakers for the background noise. You need artificial mouths for the distractor speech. And you need a head acoustic system with several packages for calculating objective audio scores. And this is very expensive and complicated to set up. You need also a data acquisition system. Of course, you need to put your measurements into a computer to analyze them. And I guess there's a sound check, other ways to do this. You could even write it in MATLAB. So this is by no means a cheap standard to fulfill if you want to measure all of this yourself. My guess is around €500,000. And that's just a guess. It could be more, it could be less, but I think that ballpark is correct. So going into the boring part of this presentation, the actual audio tests that are in the Microsoft Teams certification, or at least this curated little part of it. It starts out with they call it sanity tests, which are tests where sort of experts in the domain or in the product and the method do a call in Teams with the product they're testing. And they use a reference product on one side and then the product they're testing on the other side, I think. These are functionality tests, and that the people who do this need to know how things work and how to perform the tests. It must take place via Teams, of course. I think also there's some transition from Skype for Business going on. So it might be that it's Skype for Business. I'm not sure about that, but I guess in the future it will be Teams. There's requirements for the different rooms they sit in, the sizes, the reverberation time, and the 0.4 might be possible in a normal meeting room, but definitely not a modern one with glass sides and concrete walls. There's different background noise levels, and then you just go through relatively normal use situations and do quality assessments on a 1 to 5 scale. And it's things like turning the volume up to max and seeing if you hear an echo, and how does the noise reduction work? Does it work when people are talking at both ends at the same time? It's called double talk. And then some of them are specific to domains like handsets, headsets, and speakerphones. And some of them don't make sense for some products and others. And then there's even tests of stuff like, does the mute button work? Which is not related to audio, but it's still in the audio test spec. And the goal of these sanity tests is to identify serious issues. So if there's something completely wrong that you can hear immediately, then there's no reason to go through a very expensive and extensive test. Then there's this Windows hardware lab kit communications and hardware fidelity part, where you download this tool, Windows HLK, and it does a series of automatic tests, which are described in these Microsoft Developer Network guidelines. It measures stuff like the latency that the audio takes to pass through the drivers and other parts of this chain automatically. Then there's the actual tests that are, if you pass all of these sanity tests and the HLK, then this should start. There's Polka measurements. Polka, if you don't know, is some kind of, it's like an algorithm that measures speech quality. It's trained on a bunch of listening tests on speech, and then it can calculate a score from 1 to 5, or I think actually 4.75 as the maximum. That should be quite close to what we would get if you asked a bunch of people to rate on a 1 to 5 quality scale. And the results of this, and by the way, this is the send path. This is just on the microphone. Need to be within these limits that are, I just took them out because I thought they were, maybe interesting. Varies for different types of headsets, handsets, handheld speakerphones, personal speakerphones, etc. And then there's a standard and a premium range here. Then there's, of course, in audio, a frequency response on the microphone that needs to be within some limits in the 100 to 10 kilohertz range. You need to reposition the headset on this measurement dummy, the head and torso simulator, 3 times. The speakerphones must be in different location in the rooms, and the handset, if you're holding a phone, needs to be at different angles. Then there's requirements for distortion, noise at different gain settings, and with and without speech, and the signal level. So as I mentioned in the beginning, whatever digital output comes out of the microphone when you talk into it at different fixed levels should match some standards set by Microsoft. And this is just a sort of small overview of what's there. There's a lot more on the microphone side. And a lot of these have to be repeated at different levels and in different rooms and settings. But while that's said, some of this also in anechoic chambers. Then the receive path, so the loudspeaker part of the headset or whatever it is, conference speaker. Also the same algorithm is used, just not on the microphone, but what comes out of the loudspeaker. And there are some requirements for that here. Again, there's a frequency response, of course, with some mask from 100 to 10 kilohertz, and the same requirements for repositioning. So doing the test 3 times and taking the average. Distortion, noise, again at different gain settings with and without speech. And the signal level, what comes out of the loudspeaker when you put some kind of well-defined digital signal into it. And then also dynamic compression and several other things. Then we continue to not the microphone or the earphone, but the echo path. I guess it's sort of the loudspeaker, but yeah, so this is about how much can you hear yourself when you're talking. And there's a measurement of the terminal coupling loss. That's basically the echo at different volume settings. There is the eQuest, and this is a proprietary Polka model that Head Acoustics have, and that's why I mentioned you need this Head Acoustic stuff. And also it calculates these mean opinion scores in the same way, but based on echo or listening tests that were made with the echoes. And then it has this little thing that they accept lower scores at the maximum playback volume. Echo and double talk situations where people are talking both of them and at different volume settings. Side tone, latency, and masking rating at different volume settings. Side tone is this part of most headphones that you can hear yourself a little bit talking, but it needs to be at a certain level. Otherwise, it's annoying. And if it's too little, it's also annoying or weird. So then we go to the tests in a reverberant room with simulated background noise. And this is where you use generally a listening room with some set reverberation time in each frequency band, and then play some background noise while the audio product is in use in there, and then measure on it. The noise is from the ETSI background noise database. I put the link in the bottom of the slide here. And there's variations in the noise types and the test types depending on which product domain it is. The conference phones don't do exactly the same tests as the headsets, and there's also this category of special open office headsets that use different noise scenarios than the others, and things like that. So again, in the send direction, so the microphone side, you need to run another Head Acoustic proprietary Polka-based model that's called 3Quest. It has 3 different scores based on the input, the SMOS, the NMOS, and the GMOS. And that is speech, mean opinion score, noise, mean opinion score, and I think G is global mean opinion score. So speech, noise, and overall. It has 3 different models that calculate these. And for each of them, it must be more than some amount of mean opinion score, and the table is just too big because there's also different categories and volume levels, and yeah, and different noise scenarios also. For all of these, the boom microphone needs to be in different positions. For headsets like mine, it has a boom microphone, and for speakerphones, the talkers need to be at different positions, and for handsets, again, that it needs to be held in different angles. And then just since I'm working with listening tests, 3Quest is basically an objective version of this ITU-T P835 listening test for speech and noise. In that type of test, you ask test persons to listen to speech and noise and rate the speech quality and on a 1 to 5 scale, then noise intrusiveness on a similar scale, and then the overall call quality if it was a phone call. So it's based on that, the 3Quest method. Yeah, this is just continued the same measurements in the reverberant room. There is an output level on the receiver side, on the loudspeaker level, and especially for conferencing devices, there's a lot of requirements depending on how far you are from the conference phone. It needs to be loud enough, of course, with the background noise that you can hear it. Then there's another of these eQuest echo Polka measurements with background noise. Distracting speaker attenuation for this category of open office headsets. That's on the microphone side, where if someone is standing behind you talking, having some kind of annoying, distracting conversation, then it shouldn't go into your microphone. And there's some measurement of how much do you reduce that distracting talker level. Oh yeah, I put it there. So some other information about these Microsoft Teams tests. There's very, very detailed guidelines on how do you position your device, whether it's microphone boom arms or sound bars, extension microphones that you can put on the table in a big meeting room, laptops in different positions and stand modes. They have something called tent stand. I find that funny. Then they have special setup guidelines for Teams or Skype in some cases. As I mentioned, some of it is still maybe Skype for Business based. Calibration information for all hardware. So there's Microsoft Teams specification tells you how to calibrate all of your hardware and how to set up all of the software. And it gives you specs for all of the rooms that you need to use. So the question here, is Teams certification a guarantee of a good product? I would say for speech, yes. For communication purposes, it's at least a very strong indicator that you followed some very fixed guidelines for how to make a product that interacts well with other products of that type and has a good audio quality. But for other purposes like for music listening, there's nothing in there at all. It's only for communication. So should you get your product certified? I don't know. That's for someone in marketing or someone who knows what the cost of getting a product certified is compared to how many extra products you sell. But for the good of mankind, it's probably a good choice. Other ways to ensure good audio quality. As I mentioned in the beginning, data-driven quality assurance. Of course, I work with listening tests, so this might be biased a bit, but I don't think you should trust a single set of ears. Your whatever golden ears guy you have or girl at the office or lab, they might have tinnitus and hearing loss, and they just have bad taste, and now they like their audio adjusted. You don't know, so ask more than one person. And also don't trust a single algorithm. Just only basing your tuning on Polka and just say, I'll just put music into it and it'll be fine. No, it works for speech only, and it's not trained on new codecs and new noise suppressors. So you might even have stuff in your completely brand new noise canceling that this Polka algorithm won't catch because it's just not trained on it. It's a type of model. So yeah. And then I would suggest running listening experiments and use that data. And my email is right here on the screen for when you need that. And then also collect data from users. And yeah, I guess everyone does that with the follow-up emails from everything and ratings everywhere. But yeah. And of course, you can choose to use this team certification without actually having all of those facilities. You can still measure your frequency response on your microphone and you could maybe implement your own Polka model. You don't need to buy the head acoustics one, but yeah. So you could see it as a best practice guideline, and it's publicly available. So I don't see why not following a lot of it. And that's what I had.
Thank you very much. That was a great overview.
Thank you for listening and not falling asleep.
I had a couple of questions for you, but you've just answered them. Let me just get our panelists back in the picture here as well. Bear with me. We're used to doing these webinars. It's a bit different in a meeting mode. Okay, let's get Peter Peterson back.
Yes. The use case you're describing has become during the last 2 years very important, the communication online.
Yes.
But also what you explained is this test, you recommend it, but the test method is impractical. It's not usable to do in a development of a new product. So do we have any suggestions as to a much more practical approach to test and to make sure that we have quality communication, because that's important?
I think that just sort of cherry picking from this is a good way to go. So testing for some of the common audio things, or even just, again, I'm advertising for myself a bit here, but just running a listening test and adjusting based on that.
But cherry picking in 143 pages, I think it was, is a task. So,
yes.
So could you do some kind of recommendation or cherry picking?
I think that's a hard one to say, but yeah, either using some consultant like us, or if you have the domain knowledge yourself, then choosing what is most important and realistic to do, because of course you can't do all of these Polka measurements probably unless you have a very expensive big lab. Only the biggest companies can afford that. So maybe you can just tune the product to sound nice and run a listening test to confirm that it's not tuned by someone with a hearing loss.
Yeah.
Oh, Birwa has a question. Yes,
Yeah, it's more a comment. I think 143 pages is probably going a little bit high, because the real thing that you have to follow in the team's recommendations are actually quite a lot smaller, but it's still rather exhaustive. But saying that it's not impractical is not fully correct, because we know that people like Jabra and others are spending a lot of time in complying to these rules, because that's a way to achieve very good quality. So it's always a balance. How far do you want to go in these systems? But if you want to be real professional and you want to comply to the optimum communication, which you can only do when you apply to, for example, the team's requirements, because that allows the Microsoft system to improve on the quality that comes across from your devices. So it's a balance, but I agree with Tora that cherry picking is probably a good way to go. And if you want to really be up amongst the big guys, you probably have to take the full solution.
Yeah, the big companies, of course, they have the funding and resources to do this. So for them, it's a really good idea, and I'm sure it's doable for them in a very reasonable way. I know that some of the big companies have their own test labs and people who do these measurements, and it's completely part of their development process. So yeah, for sure. But if you were a small startup making a new headset, then yeah,
it's an undertaking for sure. Yeah, but I know. So I'm thinking here in Denmark, Jabra, EPOS, RTX, they all do it. So there aren't a lot of companies coming specifically to SenseLab to have this done.
No, and SenseLab doesn't do Teams certification. It's too expensive for us to set up.
I see. But if your target market is the corporate office world, then it makes sense to have it. But
Yes.
if not, I'm thinking about some smaller companies. I don't really know any that are team certified. If
No.
they are, yeah, for like headphones for runners or athletes or music or other
Yeah.
applications, I
There
can't
might be
think
some.
of any.
But also, it doesn't really make sense if you are making a sports headphone to be team certified. It is sort of communication focused.
Yeah, unless you like working on the move and you're running
I
through the
guess,
woods whilst on a Teams call.
Yeah.
But it also boils down to what was said in the first presentation. If you want to be better than the competition and you want to be a very professional supplier, then you have to look into the direction of these relatively complicated tests. Otherwise, you cannot get the best out of it.
Yeah, it
Yeah,
is a good way to check off.
And I guess it would also be a
lot
good
of-
idea to talk to Google and Zoom about getting their standards, because if you have a product that you want to certify, I'm sure they will be able to supply you with those.
Okay, so
Can I
they
add
have to do
something?
it?
I don't know, actually. I think they will at least have to tell you what you need to follow. So they both have forms on their website that you can fill in, and then you can ask for a meeting, and then they will see if you're worthy.
Yes. Was it Niels? Were you speaking just there?
No, it
who
was
is
me,
it?
Mihai here.
Hi, Mihai.
How's it going? I can say that I'm familiar with Teams, Zoom, and Google measurements, and maybe I can help a little bit. So I can add on like what would be the hardest ones to pass for Teams and Zoom. They're fairly similar. I mean, Zoom is based a little bit on Teams measurements. And I think the tree quest and the distractor test are the most common to fail. So it's a lot of emphasis on these ones. Also on eQuest. It also depends on the type of product that we're testing. But for headsets, it's usually distractor and tree quest that are challenging.
Yeah, that's interesting.
And is it correct that because you have different modes in the headset, can you still pass the full team certification and the other certifications for your speech mode only, and then the music mode can sound different? Or
Well, the music mode, it's totally different processing. So it has nothing to do with the communication mode. It has a different tuning.
and it's not certified?
No,
No, it's not
for
tested.
neither of these. No, you don't test the music mode.
Okay, well that's a relief. So you can still have good sounding headphones when listening to your music. Yeah, okay, great. Does anyone else have any more? Oh,
And also, if you can use Polka without having all this complicated fancy Aqua system. It's also Polka and Request you can buy separately and use without the Aqua system.
Yeah, we did that, but it's still very expensive.
where do you work, Mihai?
Jabra.
Ah, I see. So you're doing your own certification there, of course. Yeah. Does anyone else have any other questions for our panel or for Mihai? Before we wrap it up. Any final comments, Peter or Niels?
Or maybe a question to Tore, because in the beginning you said you would concentrate on communication, but could you say a few words about the audio listening tests you're performing and you could do?
Yeah, for the music side, that would be something that we could do in SenseLab and at Force Technology. Yeah, there's many ways, different ways to do it. There's the consumer study way, where we ask a bunch of consumers to rate their preference, and let's say it's a bunch of different headsets. So that's the good way to figure out, benchmark your product. Where is it compared to the competitors? And then we also have expert listeners employed in SenseLab who can do another type of testing where they, I want to say, taste the headset with their ears, and give you an rated on different attributes, as we call them, different aspects of the sound. It could be the bass strength, the bass depth, the treble strength, the brilliance, the punch, etc. And that's more like a professional wine taster telling you how is the flavor of this headset, and not so much how good does it sound. We generally don't ask our expert listeners, does it sound good? We just ask them, how does it sound in objective terms? So yeah, and then we also do other related things to headsets like comfort testing and stuff like that.
I just removed my background here so I can show you the SenseLab wheel.
Thank you. I also have it in a very small version behind me.
Do you? Just a little reminder.
Yeah, and that can be downloaded from our website. This sound wheel of attributes that can be used to characterize the sound from products, just like a wine taster's wheel or a perfume smeller's wheel. Yeah.
In Danish and English, I believe.
Yes.
Is that right? Yeah. Very handy.
Hi, can you hear me?
Yes.
Yes.
Hi, Tor.
Hey.
I have a follow-up question. So the testing and this user testing, subjective testing you do at SenseLab, is it then not only following like ITU-T standards, but also your own tests that you design yourselves?
Yes. We have, of course, we can do the standardized ITU tests, and we have done that a lot, but we also do sort of, let's say, customized tests. If there's something specific that our clients want to know, then we will do that. And actually this type of testing with where we use the sound wheel and the attributes with our expert listeners is not something we have from an ITU standard. So we kind of tailor the tests to our clients. It's not like we only have standard tests.
And the tests that you developed and the sound wheel, for example, is this something that you provide just the sound wheel itself? Do you also provide some methodology and some background into how this was developed and as a standard would, let's say?
There's a paper on this sound wheel also on how it was developed. It was based on a study of what already existed, like a bunch of words to describe sound were collected, and then we ran tests with our listening panel to boil them down. Like some of them might overlap and mean the same thing. In the end, we ended up with these attributes that are well defined. And yeah, and of course, if someone wants to run a test with that, we can be bought as consultants, both in running it or in instructing how to do it.
Fantastic. Thanks for the answers.
You're welcome.
I have one last question for Niels Martin. You mentioned at some point in your presentation that you're working with privacy and protection of data, and I know this is getting more important all the time, and it's the topic that we're going to include in one of our upcoming conferences. So I just wanted to hear what it is exactly you're doing with privacy.
Yeah, we don't do anything specifically. What we do when we do carry out the testing is that we check if anything is changed in the performance of the behavior of the device, including that of privacy or data security. So that if a device is influenced by a radio signal of some kind, can it be brought into a mode which is unintentional? Is it not safe anymore data-wise, or it could be in any other way? Does a controller reset in a way that creates an unintended or dangerous situation? So it's more general approach we have on this, because we are not ourselves experts in data communication security. Mm-hmm. We can lean on our colleagues in the development division because they work a lot with that actually. So we do have some resources for dealing with this, or for at least addressing the topic.
Yeah. Okay. Good to know.
Yeah.
Yeah.
I just have a small comment. I think it was an excellent presentation you had, Niels Martin. I liked it a lot. But I should also say that in all fairness, there are other people also that people can turn to, like Force Technology and bots. Sure. I hate to say this because you did a splendid job, but we have to balance things a bit. So sorry for commenting this.
No, but there's a lot. We have Applica in Norway, we have Verizon in Sweden, we have the UL, we have TÜV Nord, Rhineland,
Yeah,
TÜV Süd.
But it was a great presentation you had. It really, in 40 minutes, boiled it down to the essentials.
Good, thank you.
Is it correct that you're both DANAC approved?
Oh yeah,
at
yes.
Force and at okay.
Yeah.
Excellent. Well, I think we can wrap it up for today if there aren't any further questions from our audience. Thanks very much for attending, everyone. We're going to send a follow-up email with the presentations and a link to the recording, and that will of course include all of the standards and links that Thor and Niels Martin included in their presentations, as well as a questionnaire. So if you want to give us some feedback, you're very welcome. We are always open to feedback and new ideas. And yeah, keep an eye out for our newsletter and on the website for the upcoming events, and hopefully we'll see you soon. Thanks very much for joining today. And thank you, Peter, for joining the panel as well. Thank you. Bye.